Hi, Assalamualaikum. In this video, we will present our assignment. Our title is Solar Power Generation. We have 5 members. The first one is Anis Fazana binti Rajab, Khairunisa binti Kamis, Muhammad Anaf Fikri bin Zulkifli, which is myself, Nur Sasabila binti Shuhimi, and Anis Amira binti Zabri.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Khairunisa binti Kamis, and today our group wants to present about the sun's power generation. Okay, the sun is an incredible and renewable resource that has the power to fuel life on Earth and provide clean, sustainable energy to all of its inhabitants. The sun's energy can be converted into electricity through solar photovoltaic. Solar technology can be broadly classified as active solar and passive solar. Active solar is a technique include the use of the photovoltaic system, concentrate solar power and solar water heating to harness the energy. Active solar is directly consumed in activities such as drying clothes and warming of air. Passive solar is a technique include orienting a building to the sun, selecting material with favorable thermal mass or light dispersing properties, and designing spaces that naturally circulate air. The most common way of the harnessing energy from the sun is through photovoltaic panels, which is the large mirror-like panels that you have likely seen on the rooftop, handheld solar devices, and even spacecraft. These panels operate as conductor, taking in the sun's ray, heating up and creating energy and electricity. PV modules will absorb the sunlight and convert the energy into a usable form of electrical current. Solar electricity relies on the sun as its fuel source, so there is no need to drill for petroleum-based fuel, refine them, or deliver them to the site. Similarly to the wind power, solar power is a contingent upon the weather and the amount of the sunlight present in a specific location. This means that some of geographical areas lacking in sunlight or areas that frequently experience cloudy weather may have difficulty utilizing solar power effectively. Additionally, solar power is an expensive endeavor. The technologies often require a large amount of land and they can be extremely costly. Okay, next I want to present about the theory of solar power generation. Solar radiation may be converted directly into electricity by solar cells. In such cell, a small electric voltage is generated when light strikes the junction between a metal and a semiconductor such as silicon, or the junction between two different semiconductors. Photons in sunlight hit the solar panels and are absorbed by semiconducting materials. The power generated by a single photovoltaic cell is typically only 2 watts. By connecting large number of individual cells together, however, as in solar panel arrays, hundreds or even thousands of kilowatts of electric power can be generated in a solar electric plant or in a large household array. The energy efficiency of most present-day photovoltaic cell is only about 15 to 20%, and since the intensity of solar radiation is low to begin with, large and costly assemblies of such cell are required to produce even moderate amounts of power. When sunlight strikes a solar cell, an electron is freed by the photoelectric effect. The two dissimilar semiconductors possess a natural difference in electric potential, which causes the electron to flow through the external circuit, supplying power to the load. The flow of electricity results from the characteristic of the semiconductor, and it is powered entirely by light striking the cell. Small photovoltaic cells that operate on sunlight or artificial light have found major use in low power application as power sources for calculators and watches. Largest units have been used to provide power for water pumps and communicating system in remote area and communication satellites. That's all from me. Thank you.
Assalamualaikum. My name is Fazana binti Rajab. I will present about the mathematical module representing the expected total energy generation that include process and capacity. So in solar generation, there have several main parts of photovoltaic, which is the first is PV cell, PV module, PV array, and the solar radiation by PV module. So actually, photovoltaic solar cell convert the sun radiant light directly into electricity. So PV generator is produce a direct current, but the load is using the alternating current. So that's why we use an inverter to convert DC to AC. So the first of all, one individual cell can produce around 0.5 volt. So 36 cells are connecting in series that we call PV module. So from PV module, we reconnect it in series to get the PV panel. So several PV panel we connected in parallel to get the PV array. Okay. This is the IV curve that represents the relationship between voltage and current at exist condition of irradiance and temperature typically operate under normal condition. So the power delivered by a single PV panel is the product of the current and the voltage. So in short circuit condition, the positive and negative lead are connected together, so the voltage that across the cell is at minimum, but the current that flowing out of the cell is at maximum. So in open circuit condition, the solar cells are not connected to any load, so the current will be at minimum, but the voltage across the cell is at maximum. So the combination of current and voltage, which is the power, reach at maximum point as shown in the curve. So in the other word, the point that cell generate maximum electrical power is shown in the area of the green rectangle. So MPP is actually maximum power point is equals to the current times by voltage that we measure in the watt. So as we can see, in parallel connection, the voltage is remain the same, but the current added. So to get the power, we use the basic formula, which is current times by voltage. So we get 240 watt. So actually, for higher current requirement, many single PV panel are connecting in parallel. So if we see from the series connection, the voltage are added and the current is remain the same. So again, we find the power using I times V. We got 240 watt. So for higher voltage requirement, many single PV panel are connecting in series. Okay, furthermore, this is the solar PV system sizing. We first solar panel load sizing, which is to determine the power consumption demand by calculating the total watt hour per day. And second, solar PV array sizing. Different size of PV module will produce a different amount of power. And third, solar inverter sizing, which is the sizing of solar inverter is very important for conversion happen smoothly. Fourth, solar charge controller sizing. Solar charge controller is rated with ampere and voltage capacity. So choosing a solar charge controller that match to the voltage of PV array. And the last, battery sizing. Choose a battery that has capacity equals to or more than the solar panel. So last but not least, as example, Solar Potential Malaysia has among the highest potential for solar intake as strategically located near to equator. So the monthly solar irradiation for Malaysia is estimated around 400 and 600 megajoule per m square. So the irradiation is higher during the northeast monsoon between November and much. So generally, Malaysia has high potential for solar generation, taking into consideration its hot and sunny weather all year. So the estimate potential for solar generation can reach up to 6,500 megawatts. So that's all from me. Thank you.
How many of the population got access to the electricity produced? China is the largest market in the world for both photovoltaic and solar thermal energy. By the end of 2019, a cumulative amount of 629 gigawatt of solar power was installed throughout the world. By early 2020, the leading country for solar power was China with 208 gigawatt, accounting for one-third of global installed solar capacity. As of 2020, there are at least 37 countries around the world with a cumulative PV capacity of more than 1 gigawatt. Percentage of solar power generation in the energy mix. Solar share of the power generation mix has steadily increased over the 10 years, and it now accounts for 27% of renewable generation, albeit only 3.2% of total power generation. In 2019, just over 2% of global electricity came from solar. Are there any government commitment towards promoting a sustainable and cleaner production of the solar power generation? Yes, in Malaysia, the government has announced that the national RE target has been revised a more aggressive target to reach 2,000% of RE penetration by the year 2025. Approximately 50% of the target will be coming from solar technology, while another 50% will come from non-solar technologies. Solar technology is considered the easiest RE technology to be deployed, and also the low price that can be offered by solar makes it even more attractive. The other non-solar technologies need strong support from the government in terms of incentives to ensure project viability. So I need to compare country Thailand size and additional 11 megawatt were added to the initial capacity of 73.16 megawatt in May 2013. Developed by Lobori Solar Farm, located 100 km north of Bangkok. Date operation April 2010. Singapore, building a 10 megawatt solar installation on the roof of its warehouse, Jurong Port Road, 1965. Malaysia, in 2015, total installed capacity will reach 640 megawatt. TS Solar Tech, Penang Science Park, 2010.
Hi, I am Norsal Sabila binti Shohaimi. I will talk about advantages and disadvantages of solar power generation. So, we go for advantages first. First is renewable energy source. It can be harnessed in all areas of the world and is available every day. So, we cannot run out of solar energy, unlike some of the other sources of energy. Solar energy will be accessible as long as we have the sun. Second, it can reduce electricity bills. Wow! Since you will be meeting some of your energy needs with the electricity your solar system has generated, your energy bills will drop. How much you save on your bill will be dependent on the size of your solar system and your electricity or heat usage. Third, it is low maintenance cost. Solar energy systems generally don't require a lot of maintenance. You only need to keep them relatively clean. So, cleaning them a couple of times per year will do the job. Most reliable solar panel manufacturers offer 2 to 25 years warranty. Last but not least, it is technology development. In the solar power industry is constantly advancing and improvement will intensify in the future. So, innovation in quantum physics and nanotechnology can potentially increase the effectiveness of solar panels and double or even triple the electrical of the solar power system. Next, I will talk about these advantages of solar power generation. First is high initial cost. The initial cost of purchasing a solar system is fairly high. This includes paying for solar panels, inverter, batteries, and wiring and the installation. Nevertheless, solar technology are constantly developing, so it is safe to assume that the price will go down in the future. Second, it is weather dependent. Although solar energy can still be collected during cloudy and rainy days, the efficiency of the solar system will drop. Solar panels are dependent on sunlight to effectively gather solar energy. Therefore, a few cloudy, rainy days can have a noticeable effect on the energy system. Next, solar energy storage is expensive. Solar energy has to be used right away or it can be stored in large batteries. This battery used in off-the-grid solar system can be charged during the day so that you can be use the energy at night. This is a good solution for using solar energy all day long, but it also quite expensive. The last disadvantage is it uses a lot of space. The more electricity you want to produce, the more solar panels you will need, as you want to collect as much sunlight as possible. Solar PV panel requires a lot of space and some roofs are not big enough to fit the number of solar panels that you would like to have. Next, I will talk about environmental issues related to solar power generation. First is solar energy facilities necessitate large area for collection of energy. Due to this, the facility may interfere with existing land uses and can impact the use of areas such as wilderness or recreational management area. Second, as energy system may impact land through material exploration, extraction, manufacturing, and disposal. Energy footprints can become incrementally high. Third, the construction of solar facilities on vast areas of land imposes clearing and grading, resulting in soil compaction, alteration of drainage channel, and increased erosion. Fourth, the construction of solar energy power plants can pose hazards to air quality. Last, the release of soil carry pathogens and result in an increase in air particulate matter, which has the effect of contaminating water reservoirs. Thank you, that's all from me.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Anas Fikri bin Zulkifli and I will conclude what we get from this assignment. Based on our very useful research, we found that solar energy can be converted to electrical energy through solar photovoltaic modules. Solar technology can be classified into two categories, namely active solar and passive solar. Active solar technique include the use of photovoltaic system, concentrated solar energy, and solar water heating to harness energy, while passive solar techniques include orienting buildings to the sun and designing space that distribute air naturally. The most common way to harness energy from the sun is through photovoltaic panels, which are large mirror-like panels. Solar electricity depends on the sun as its fuel source, so there is no need to drill for fuel like petroleum, filter it or send it to the site. Having similarities to wind power, solar power depends on the weather and the amount of sunlight available in a particular location. The power generated by a single photovoltaic cell is usually only 2 watts. By connecting a large number of individual cells together, as in an array of solar panels, hundreds or even thousands of kilowatts of electrical power can be generated in a solar power plant or in a large household arrangement. The energy efficiency of most photovoltaic cells today is only about 15 to 20%. And since the intensity of solar radiation is low, so we need a large and expensive installation of such cell to produce a modest amount of power. The two unequal semiconductors have a natural difference in electrical potential, which causes electrons to flow through an external circuit, in turn supplying power to the load. The electrical current results from the characteristic of the semiconductors and is powered entirely by the light that hits the cell. Small photovoltaic cells operating on sunlight or artificial light have become a major use in a low power application as a power source. For example, calculators and watch, while larger units have been used to supply power to water pumps and a communication system in remote areas and communication satellites. Electricity generated from renewable sources such as solar PV, biomass, biogas, monohydrosolid waste may be 11,227 gigawatt by 2020, according to the Renewable Energy Action and Policy Plan (NREPAP). In addition, solar energy generating shows no sign of greenhouse gas emission, making Malaysia move forward towards a greener and cleaner energy. The advantages of using solar energy are it is renewable energy source. Thus, we will not run out of solar energy. Unlike some of the other sources of energy, besides, it can reduce electricity bills, have low maintenance costs, and constantly experience technology development. While the disadvantages of solar power generation are the initial cost of purchasing a solar system is fairly high. It is weather dependent. The solar energy storage is expensive and uses a lot of space. Besides, in the point of generating electricity at a utility scale, solar energy facilities necessitate large areas for collection of energy. The construction of solar facilities on vast areas of land imposes clearing and grading, resulting in soil compaction, alteration of drainage channels, and increased erosion. Conclusively, the solar power generation are a very good alternative power source for the humankind. Government should take action such as do some research and focus on the development of the infrastructure needed to maximize the usage of solar power generation in Malaysia. Although the starting cost to make this plan into reality is a bit high because of the price of solar panel is quite expensive, but in exchange, we all know it will give a lot more profit back to the government. Last but not least, Malaysia has a high potential for solar generation, taking into consideration where it is hot and sunny weather all year round. So that's all from our group. I hope everyone who watched the video can get benefit from this. Thank you.